In this video we will explain how to use the Carry 7 software to simulate the dose rates expected for your flight. We will walk you through a typical analysis procedure, in which you can compare the calculated dose to what your device measured. The Carry 7 software, developed at the Federal Aviation Administration Civil Aerospace Medical Institute, calculates the effective dose of galactic cosmic radiation received by an individual on an aircraft. The Carry 7 software is free to download from the Federal Aviation Administration's website for Windows and Linux operating systems. The link is provided here as well as on our website. After you have downloaded the software, you need to convert the log file produced in the previous analysis step to a format that Carry 7 can read and process. Refer back to the Part 2.1, Analyze Your Data section if you don't have this file yet. Next, you will need to run the converted files through the Carry 7 software to calculate the dose at each point along your flight path. Lastly, we will plot the calculated and measured dose rate as a function of altitude. You can download the Python script to convert your log file to the Carry 7 format from the Cosmic On Air website. You will need to provide the path to the folder where you would like the converted files to be stored, and the path to the new log file that you created in Part 2.1 of the analysis. The script will produce two files that will be used as inputs to Carry 7. The first will be used to calculate the dose for all radiation types, and the second will be used to only calculate the neutron dose. We'll explain why this is needed later. The script then opens the log file, initializes a set of lists, and then reads through the file line by line. The location, time, and dose rate are separated and stored within the relevant list. Once all the entries have been extracted, the file is closed. The script then reformats the date and time parameters and separates the latitude and longitude coordinates into degrees and minutes. Finally, the data are formatted and written to the 2.loc files. This step is almost identical for the total and neutron-only files. You will notice that the total dose file has a P0 variable, while the neutron dose file has a P1 variable. This difference tells Carry 7 which particle to calculate the dose for. The Carry 7 software can calculate dose contributions from many types of radiation. If you would like to investigate the different contributions, all you need to do is change the P variable in the conversion code to one of the particle numbers listed here. The reason that we create two different .loc files is because the current sensors are not capable of measuring neutron radiation. To compare the Carry 7 theoretical dose rates to your measured data, you will need to subtract the neutron contribution from the total dose. After you have run the script, you should have two .loc files produced. You will need to copy these files to the same folder in which the Carry 7 software is saved. Our next step is to run the .loc files that we created through Carry 7. After launching the software, it should present the following menu. Since we want to compare the simulated dose rates to your own measurements, we need Carry 7 to use the same altitudes and geographic coordinates. To do this, you need to select option 4 and press enter. After selecting option 4, you will then be taken to the next menu. We want to calculate the dose rate at each point within our .loc file. This means that you need to select option 2. The next page will present all the .loc files stored in the same folder as the Carry 7 software. You can then enter the number associated with the .loc file that you would like to process. The total and neutron files will need to run separately. Once you have selected your file, the program will begin to calculate the dose rate at each point. This step may take quite a while, depending on how many measurements are contained within the file. Once complete, a.ans file listing all the GPS coordinates and corresponding dose rate in microsieverts per hour will be created and stored in the same folder as the Carry 7 software. The file contents should look something like this. If you would like to explore some more of the tools that Carry 7 provides, you can use their user manual linked on their website. This Python script can be used to plot the calculated dose rates from Carry 7 alongside your measured data. First, you'll need to provide the paths to your total and neutron-only output files that were produced by Carry 7, as well as your new .log file. All three of these files are stored in the same folder here. The next step is to open the total dose Carry 7 output file, extract, and store the dose rate and altitude data. We do the same thing for the Carry 7 neutron-only dose output file, as well as the new .log file. You might notice that there is a calibration factor that has been applied to the measured radiation data. This factor accounts for the variation between different detectors. It was calculated by comparing measurements of the same flight, taken with multiple detectors. Following this, the script checks that the number of entries within the Carry 7 total and neutron-only radiation files are the same. It does this so that it can subtract the neutron contribution from the total dose rate, which can then be compared to the measured values. Finally, the script produces a plot of the measured dose rate alongside the total and neutron-subtracted Carry 7 dose rates as a function of altitude. Once again, the X and Y axes are limited to avoid plotting any radiation that was detected prior to the flight. As with the other pieces of code, these limits can be changed. If all goes well, you should see a plot that looks something like this. The total dose rates simulated with Carry 7 show good agreement with our measured data in the overall shape. However, they overestimate what we actually measure. When the neutron contributions are removed, the agreement with the measured data is much better. We're still working on ways to measure the neutron contributions as well, so keep an eye out for updates in the future. Thanks for watching. I hope that you have enjoyed analyzing your data and will continue investigating solar flares with us.